So far, we've learned what a complex number is, we've even learned how to graph it, and we learned how to add, subtract, and multiply it. And where I left off in the last video is how do we divide two complex numbers. So I said, let's say I have one complex number, z1, and that equals a plus bi, and I want to divide that by z2, which is c plus di. So let me ask you a question, and I touched on this in the last video, and let me do it in a different color here. We know that a plus b times a minus b is equal to a squared minus b squared, and you can multiply it out if in case you're not sure. You remember it's just a times a plus b times a plus minus a times b minus plus a times a, and you'll get this. I don't know if I said that right, but you know how to do this. Anyway, there's a review if you need to do it. So given that, what is c plus d? What happens if we do something very similar with a complex number? If we say c plus di times c minus di. Well, in this case, a is c and b is di, right? So this is just going to be equal to c squared minus di squared, and that equals c squared minus d squared I squared, and that equals c squared minus d squared, and I squared is -1, right? So this is going to be multiplied by -1, so it cancels out this negative, so you get c squared plus d squared. That's interesting. When I multiply a complex number times this other number, which is very similar to it, but it's kind of the imaginary part goes in the other direction. When I multiply the two, I get a completely real number. All of the i's disappear. And in general, this number, if we call this z, well, in our example, this was z2. So if we say that z2 equals c plus di, the quantity c minus di is called its conjugate. And that's just good terminology, you know. And the sign for conjugate is that line over the top. So the conjugate of z2 is c minus di. Or you could say the conjugate of c minus di is equal to c plus di. Or you could say it the other way around. The conjugate of c plus di is equal to c minus di. And notice, we're just switching the direction in the imaginary, along the imaginary axis when we take the conjugate of something. With that said, let me erase that and go back to our original problem, because the conjugate is the tool we're going to use to divide this. So we know when we multiply an imaginary number times its conjugate, we get a real number. So, and we know also if we can multiply anything by 1 and we get the same number. So let's multiply the numerator and denominator of this expression by the conjugate of the denominator. So let me do that. So the conjugate of the denominator is going to be c minus di. So it's c minus di over c minus di, right? This was c plus di, so this is its conjugate. And so what do we get? So in the numerator,